I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
The podcast that helps you understand the chemistry of your everyday life.
We're back, baby.
Oh, yeah. Back in action.
This is our holiday gift to you. We are here with not only a full episode, back to our normal full episode, regularly scheduled programming. But it's the long awaited for, much anticipated. Everyone has asked. Finally, I get to tell you what is the chemistry of coffee.
Oh my gosh.
I know.
This has been requested a ton of times.
A ton of times.
And I have requested it too. Mm-hmm. And funnily enough, it is also one of the things that Melissa and I used to kind of fake argue about, where I'd act like, hey, Melissa, I'm doing chemistry over here. I'm making coffee. And we would just sort of, I would act like I knew everything about chemistry just because I knew how to make coffee.
And it turns out that you were doing chemistry, but not a chemistry reaction. So we'll talk about it. Uh-oh. You were doing chemistry, though.
It's still chemistry.
Still chemistry. I thought this would be an appropriate way to come back from a break. Mm-hmm. We also had a chance to ask our hopeful guest that we wanted, and they're not going to be able to do it at this time.
Yeah.
But maybe in the future.
Yes. So keep your ears peeled for what could be a cool guest someday at some point on this topic.
But once we heard back from him, we decided, all right, I decided, I guess.
Yeah.
I decided, all right, let's take the plunge. Let's welcome everyone back with the one we've all been waiting for. Mm-hmm. I also thought this would be a good one because today is a holiday in America. It's Thanksgiving Day, which is all about food. And although I don't appreciate the roots and the history of America and with Native Americans, and I think we need to take time to learn about that, I do really appreciate time to rest and time to be with your family.
Yeah. And
time to gather together, make good food, or be with your friends, your chosen family, whoever it is. Mm-hmm. I think that is really important. And we always like to do a special episode because it's always on a Thursday.
Yeah.
And so are we.
Totally.
So hopefully you guys enjoy this and get to listen to it while you're traveling wherever you're going, or if you need a little break, going on a walk to burn off some of those calories.
Yeah. Or get a little bit of like non-social time to kind of like decompress.
Yeah.
Or whatever, if you've been hanging out with a lot of people. And we also wanted to, before we start this episode, remind you guys of some of the changes of our schedule going forward. And so from now until Melissa finishes her PhD, most likely.
Which is hopefully coming this spring.
Yes. Awesome.
No later than August 2022.
Very cool. We're all cheering for you.
Thank you. Wow. I've probably, that's amazing to think about.
Oh yeah. Everybody. I mean, who wouldn't, You guys are cheering for her, right? I think that's a yes.
I think probably. Hopefully, if they're here, they're probably cheering.
So in order to help have still a consistent delivery of new chemistry content for you guys, but also to be able to give Melissa a little bit more time to balance her workload of PhD stuff and teaching, and also the podcast, we'll be having one new chemistry content episode every other week. Mm-hmm. But we'll have something for you every single week. And between the normal episodes, we'll have things like Q&Rs and maybe some experiments in there somewhere.
Right.
And then also republish some older episodes that maybe some of you guys have not heard before.
Right. So it'll be new episode, bonus, new episode, rebroadcast, new episode, experiment, something along those lines is going to be our schedule moving forward, just to get me through the end of my PhD, which is one of the hardest years typically. There's a lot of weight and a lot of deadlines and a lot of writing.
Yeah. And we talked a little bit more in detail about this at the end of our previous fall mini. So if you got more questions there, we kind of talked longer about it there. But don't hesitate to reach out if you've got any other questions.
And I'm glad that we took time to do those fall minis because I have stockpiled up on episodes I'm very excited to talk about.
Nice. Dude, nice.
So, yay. Okay, and starting with today's.
Heck yeah, I'm excited.
So are you ready?
Very ready.
Okay, brewing coffee is really, if you boil it down, it's something called solid liquid extraction.
Okay.
This is a chemistry technique. It's not a chemical reaction.
Okay. But what's good about this is that extraction is a word that is used in the coffee world. Obviously, tons of baristas and stuff like that don't know what they're just using terms that they've heard and stuff. But that, at least so far, that term is somewhat accurate.
Checks out, right?
Nice.
That's what I was thinking. I thought you had said it was an extraction before.
Yeah.
And I wasn't 100% sure because often we use a different type of extraction where we're using two liquids.
Okay.
But I did make sure this technique, I looked in my old lab manuals, and it is a solid liquid extraction.
Nice.
So I'll tell you what an extraction is and what we use it for in chemistry.
Okay.
So in chemistry, you can easily mix two things together and heat it up or stir it or whatever and make a reaction. And we've talked about in the past, a lot of times people think you mix A plus B and then you get 100% C.
Right.
But actually more of what happens is you mix A plus B and then you get some C, D, E, F, and some A and B that didn't totally react are all in there.
Right. Right.
So it's kind of a mess.
Right.
I was trying to think of a good analogy for this, and the best thing I could come up with, which is not exactly like that, but it takes you like 30 seconds to mix a bunch of different color of beads into a bowl or a jar or something. But then it takes you a long time to separate those back out.
Right. Right.
That is kind of what we do in chemistry. You mix two things together and you get a lot of products, your main product, hopefully, and then side products, and then you're purifying them.
Right.
So you can spend an hour making new things and then 3 weeks purifying it.
See, okay.
That is what we spend a lot of time doing in the chemistry lab, not making new things, but actually purifying that and then making sure we made what we think we made.
Got it. Got it. Interesting.
So one of those techniques is called an extraction to purify, a purification technique.
Okay.
So extractions are used both to purify one thing, say something we want, take out something we want, but also to kind of wash away things that we don't want. So a good example of an extraction is if you have a mixture of a solid metal and a salt. Say you have a penny and somehow it got coated with salt crystals, like table salt crystals. Maybe it got water at the ocean and it crystallized out all this salt.
Okay.
So you're thinking, okay, I want my penny. I don't want it to have salt all over it. So I know that salt is soluble in water. It can be washed away by water. Metal isn't washed away by water.
Right.
So that's kind of an extraction. You are using some kind of solvent that can dissolve one thing to get rid of that and then keep the thing that you want.
Nice. Nice.
Something else I thought about is we've talked about capsaicin before. Go back and check out the episode where we talked about what makes spicy things hot. We talked about capsaicin. And capsaicin is soluble in oil. That's why people drink milk. It's soluble in fats and oils, but it's not soluble in water. So if you have capsaicin and you drink water, it just kind of moves it around your mouth. It doesn't dissolve it or wash it away.
Right.
But salt does dissolve in water.
Right.
So if you had a mixture of those two things, you could put some water in there and take the salt out and leave the capsaicin behind, perhaps.
Okay. I see.
So that's kind of the idea of an extraction. You're looking at what you have and what you want, and you're trying to think, what solvent system can I use to get the thing that I want out?
Yeah. Okay. I see what you're saying.
Okay. So coffee is really, the brewing process is really a purification technique. So you've had a series of chemical reactions, some of them by nature, some of them by people, to get you this bean that's in front of you. It's all ground up, and it's essentially a pile of a bunch of different molecules.
Okay.
And some of them are tasty, delicious molecules, and some of them are not tasty and delicious.
Right.
So the chemical reaction's already been done, but you need to somehow isolate just the things you want
Right. Right.
from that pile of molecules, your coffee grounds.
Yes, so for the same reason that we don't just spoon coffee grounds into our mouth.
Yes, because there's some things you don't want. There's things that taste bad in there.
Yeah.
I guess some people eat chocolate-covered coffee beans. I don't know. That doesn't seem tasty to me.
Yeah, that's true.
But you're really trying to just capture those things that are going to taste good in your mug.
Yes.
And leave behind the other things.
Right.
You're extracting what's desirable and leaving behind the other things.
Right.
So in a chemistry lab, when we're going through the process of trying to decide how to keep the things we want and get rid of the rest of it, we consider what solvent we want to use.
Okay.
And solvent is a liquid that you dissolve something into. So we would consider, is acetone, like nail polish remover, is that going to be the best solvent? Maybe water, maybe alcohol. You can go through all these different liquids and think about what's going to dissolve the best.
Right.
But when you're making coffee, there's only really one option for humans to safely take in.
Right.
And that's water.
Yeah, because our goal is to drink it.
Right.
And put it in our body.
So acetone, not going to be an option.
Yeah.
Although it'd be fascinating to brew coffee with those other things and see what it looked like. You couldn't taste it.
Yeah.
Maybe the ethanol you could taste.
Yeah.
Alcohol coffee, that'd be weird.
That would be weird.
So, but that would also be a really big challenge to switch to alcohol because that would have a totally different solubility of the things you want and the things you don't. So in coffee, we know that our solvent is going to be water. So there's one thing we can do where we can change how much of something dissolves in water. Can you think of what that would be?
Would that be increasing the temperature
It would
of
be,
the water?
Yes. So manipulating the temperature of the solvent will change how much of the thing you're dissolving, that's called a solute, can go into it.
Got it. Yep.
And everyone has experience in this in their daily life. We wash dishes in hot water because more stuff dissolves in hot water. We dissolve our sugar in hot tea before we ice it.
Right.
For iced tea because it's more easy to dissolve that sugar in the hot tea.
Yeah.
There's all kinds of examples of this. One thing for me is hot chocolate. We have powdered hot chocolate that we make a lot, and it is really different if you put the powder in the hot water before or after you add the cold milk to it.
I see.
It makes a big difference in how easily it dissolves.
Yeah, that makes sense.
So we've probably all experienced this to one degree or another. And if you've ever made rock candy where you dissolve sugar in water and let it form crystals to make rock candy, you'll know that you heat up that water to put even more in there to make a super saturated solution.
Got it. So
manipulating temperature impacts solubility. If something's hotter, you can have more things dissolve in it. If it's cooler, less things dissolve in it. So that's the only tool we have in our pocket for coffee to manipulate how much of what we're dissolving.
Right.
Because we already know that we're using water as a solvent. And actually, most of the tasty and not tasty molecules in coffee are all soluble in water.
Okay.
So the only thing we can do is manipulate the temperature. And actually, one thing I read said that there are hundreds of different molecules that give coffee its flavor. And many of the ones that taste good have a higher solubility in water. So they will go into water more quickly than some of the more bitter molecules.
Yeah.
So we typically aim to heat water to slightly below its boiling point when we're pouring it through our coffee in a pour over or something like that. If you're heating the water yourself, because that's just the right sweet spot to extract the molecules we want and leave behind everything we don't.
Yeah.
If you heat it up hotter, those other things will more easily dissolve as well. And so you maybe will get more bitter, more burnt tasting coffee.
Yeah.
And if you leave the water in the grounds for too long, it'll have time to extract not only the easily extractable ones, but it'll give time for other ones to come through into that coffee.
Yeah. It's not, I don't have a source for it, but a lot of baristas, if they have a coffee that's too darkly roasted, then they will experiment a lot with dropping their water temperature down to so in Fahrenheit it's 212 degrees for boiling point, or Celsius is 100.
Right.
In Fahrenheit, they'd be willing to drop it down all the way to 200 or even 195 because they don't want the sooty kind of carbony, burnt things that are in that coffee that's too dark. But for a lot of light roasts, they don't worry as much at all.
Interesting.
But it just they'll play with it depending on the darkness. Obviously, that's not.
Right.
It's just like that's an anecdotal, but it's out there enough that a lot of baristas, that's what will determine
they'll mess with that.
Yeah.
Well, I will say that we're probably going to have another episode on the chemistry of roasting coffee, but I wanted to start with the brew because I feel like that's the part that most of us interact with.
Yeah, totally.
So that's pretty much it. That is the chemistry behind brewing coffee. It's actually very complicated because you have to be able to get the water to be exactly to where you want to get most of the molecules you want and not really the molecules you don't. And for each one that has gone through different chemical processes, you have a different batch of molecules sitting there. And so, like you said, different roasts could bring different things that are desirable or not desirable. And so really every single coffee extraction process is a pretty complicated chemistry technique.
Yeah.
It's just that most of us doing it don't know anything about the chemistry behind it or how to manipulate what's desirable and what's not.
Yeah, definitely.
So I thought that was super interesting. And it's simple to understand. We do a lot of extractions, I think, in day-to-day life, but it's difficult to execute.
Yeah.
Oh, and a book I was reading that I really liked, an organic chem lab survival manual, said some extractions are washing things away. Like if you're making soup and you rinse the vegetables off, and some extractions are keeping the things you want. Like when you're boiling those vegetables and you're extracting some of the flavor out into the liquid, but you want to keep it.
Yeah.
So that's kind of a nice way of thinking about it.
Yeah.
That was Dr. Zubrick, Dr. James Zubrick, in his book, The Organic Chem Lab Survival Manual. I love that book. So I thought that was really a good analogy.
Yeah, that's very cool. Do you want to try to give my sort of sum up of this?
I kind of do, but I also want to do Coffee Corner with Jam where you talk about your brewing process to see how it stacks up. Because also,
nice.
The listeners want to hear what you do in roasting and brewing coffee.
Yeah.
So I both want you to tell me the chemistry behind it, but I also want me to tell you how your brewing methods stack up to what I said.
Okay, cool. Yeah, so if you had not heard an episode where we've talked about coffee, because normally if we talk about coffee, it's because I'm relating something Melissa's talking about to coffee because I like coffee a lot.
Right.
And know a lot about it. Or it's because I just share about it in my hobby time about like what we did during our weeks. And so if you're newish to our podcast, I'm a huge snob of coffee and
coffee doer.
Yes. And I roast my own coffee in a little roaster that I have. And part of that's because I'm also cheap. So, but I can control a lot of the things that I want out of coffee. So anyway, the way that I brew coffee most of the time is using a pour over, a V60, which is a really common, probably the most common out there pour over system.
And very similar to a filtration that you might see in a lab. I could see us using something like that.
Yeah.
To rinse off stuff we don't want and keep the solid that we do.
Yeah. And most V60s use a paper filter to allow the water or the solvent to pass through.
Right.
Without the solute, the coffee grounds.
Right.
Passing through so that we can leave behind something that we don't want.
Right.
And take what we do. So a lot of V60s work with a paper filter. I heat my water all the way to boiling point because I roast my coffee very light.
Okay.
So I found that lets me get the most that I want out of the coffee that I'm making. And sometimes when I messed with, just again, this is just anecdotal, brewing with a lower water temperature.
Right.
I sometimes felt like it wasn't very strong. Like it was notably weak. Like maybe it didn't dissolve as much of the stuff I want.
Definitely it wouldn't have. If it was a lower temperature, it would have less ability to dissolve as much stuff.
Yeah. So I'd noticed that. I used to play with that back at the very beginning of getting into brewing my own coffee with the pour over. And so now I pretty much always do 211 degrees Fahrenheit, or what would probably be like, 99.5 or something like that degrees Celsius. And I pour the water over the coffee, the coffee grounds, and as it mingles in there or whatever, it passes through, and then only the water that has then been able to dissolve stuff from the coffee makes it out the other side.
Yep.
And it's hard to kind of mix these two worlds of mine. It's like
it really is a lot like filtering in chemistry, but usually the solid is what we want to keep. So if you've ever been in a chemistry lab and you mix stuff up and you put a bunch of stuff in a filter, you're trying to keep the solid usually and get rid of all the solvent.
Oh, I see. Yeah.
But in coffee's process, it's what you would do in a chemistry lab, but reverse. We want to keep the solvent and we don't care about what's been left behind. The solid's left behind.
Yeah. And one of the things I think is so interesting about how things like coffee have come about is that so much of it just kind of makes logical sense by how civilizations have worked for a long time.
Right.
It's like find ways to use all the plants and all the, animals and all the whatever else we have. And that someone would think to put some coffee beans in some hot water makes total sense.
Right.
That's how tea happened, you know, as well. And lots of medicines and stuff like that. So just the idea of like, before any science was known, let's put this thing in hot water and see what happens. And we know we can drink water. So if we put something in hot water, we should be able to drink it.
Yeah.
And I just love how there's so much interesting science there, but it has happened for, thousands and thousands of years. Who knows how long people have been putting coffee and water together.
Well, I thought your explanation was good. I want to make one change.
Okay.
You said this solute is what's left behind. Solute is what you put in the solvent. So technically, while the water is in the filter with the coffee, that's solute. But after the water is passed out, the brown stuff that makes your coffee brown, whatever is dissolved in your water, that is solute in your solvent.
Is there a word for what you leave behind, or is it just...
This is different. So a solid liquid extraction is using liquid to take what we want out of solid, or using liquid to take what we don't want out of solid. And so that's different than filtration. But if we were filtering, say you had mixed a bunch of coffee and water together and then you were filtering out the liquid.
Yeah.
In that case, the coffee, the liquid that passed through, that's the filtrate. And the solids left behind are either called like residue or filtration solids. I've heard them called all kinds of things.
Got it. So solute is what we dissolved into this solution.
Yes. And I remember it because when I was in high school, my high school chemistry teacher, Mrs. Mollis, wrote solvent on the board, but put a huge V in the middle of the word solvent, and then wrote solute inside the V.
Ah,
so it's like the solute is what goes in the solvent.
Nice. I see.
Yeah.
That makes sense.
So really your coffee is a mixture of solvent and solute.
Right. Yeah, I think the first way you said it, I thought it was like a way of describing the material and just the stuff.
Right.
And so then I thought it was still that even after, but we just had chosen some things from it.
Right.
That's what you're saying. And so it's actually the stuff that we did dissolve into
the water. Yes. Yeah. So that's your chemistry lesson for today.
Nice.
Feels good to be back.
Yeah, absolutely. And like coming back with a bang, Yeah,
coming back with the thing we've all been waiting for. And I did not put all the names of people who requested this episode because there were a lot and it's hard to search through our Instagram messages. But thank you to everyone who wrote in and expressed your desire to learn about coffee and the chemistry behind it, because this was really fun to put together.
Yeah, and thanks to you guys for being patient on us actually finally getting to it. So,
but I do want to say that I'm hoping that I can do an episode on how coffee is roasted and the chemistry behind that, and an episode on decaffeinating coffee.
Nice.
So all those are things I'm interested in, but it's difficult to get good references that aren't random people speculating about the chemistry of coffee, but to actually find sources about the actual chemistry of coffee. I did find a research group whose focus is on coffee.
Nice.
So, and maybe even an episode on the difference between a hot water solid liquid extraction and a cold water solid liquid extraction.
Yeah, I could definitely see a lot of cold brew fans out there wondering.
Oh, I'm a cold brew fan.
Yeah.
I like cold brew. I'm raising my hand.
Yeah.
I'm one. I really like cold brew more than hot brew. I pretty much only drink hot brew because I'm cold.
Yeah. Yeah. There's a lot of people out there like that. I think there's a number of people who I'm friends with who have said something to the effect of I thought I didn't like coffee and I tried cold brew and I like cold brew.
Cold brew is the only thing I could probably drink black.
Yeah.
But why drink it black when you can put milk and sugar in it?
Because then you could drink it black, actually. If you don't put the milk and sugar in, then what you have before you add, so in chemistry, we call it ingredients.
In chemistry, I was like, what is he going to say?
I just start teaching you. I'm like, when you add stuff, Melissa, you've added stuff.
I kind of wanted to see if I could think of a way that you teach me, but what I do want to do is the coffee corner or jam at the end of each episode so you could educate us about coffee because you know more about the practical implications of doing an extraction and doing all of these things in this setting.
Yeah. Yeah.
Whereas I know more about the science behind why does heating it up work better? It's because solubility increases with heat.
Yeah.
And what are we doing right now? We're taking we want to hit the sweet spot of taking the molecules we don't that are soluble in water and leaving behind the ones that we don't want or whatever it is.
Can I add something to that coffee corner and also check it with you while I say it out loud?
Absolutely. Go for it.
So one thing that probably is pretty important is talking about grind size. If you're someone who just buys your coffee pre-ground, then you're not probably worried about it, but you might end up encountering sometimes where depending on how you brew your coffee, it's super different results.
Right.
My understanding, and Melissa will correct me if it's wrong, is like a layperson's way of putting it, I guess, is that grind size matters a lot because when you have either really coarse, like much larger pieces of coffee, or really fine, when the finer you get, the more surface area you have of each particle or whatever.
Yeah.
And so it allows a lot more chance of dissolving a lot more of the stuff.
Yeah.
And so sometimes people will be like, man, this coffee was so strong and it was ground really fine. Or it was really weak and it was ground really coarse. Something like that seems to be my understanding of the reasoning there.
I could definitely see that. So I tried to find out about that, and there weren't a lot of at the surface of the coffee and the water interfacing science about that I found easily.
Yeah.
But one thing said it was through osmosis, but that doesn't really make sense to me. So I'm not 100% sure. But when I was thinking about grind size, that was what I came up with as well, is if the solvent has more opportunities to come into contact with those molecules that it wants or doesn't want, it can dissolve more of them faster, right? Yeah. Either the desirable or the less desirable.
Yeah.
And you can imagine if you have a huge block of sugar and you drop it into hot water versus if you have a bunch of small pieces, the small pieces are probably going to dissolve a lot faster, you know, or a large crystal of salt versus that same weight of salt all ground up, that is likely going to dissolve a lot faster because each water molecule can surround that thing.
Yeah.
Whereas if there's bigger pieces, it's harder for the water molecules to penetrate in and get everything it wants. And that water is passing through relatively quickly. Yeah. I mean, you know, so that was my theory, is that if it was a finer grind, it would be able to interact. The water molecules would have more chance to get at the molecules that will be dissolved. And so it can have more opportunity to dissolve more things, good and bad.
Yeah. So in your use case as a listener, there are some brew methods, we could go into that, but just as a general way of not going too deep, some brew methods are great for finer grinds because you can get the strength you need and want, and that's not too strong or too weak for you.
Right.
And other, brew methods are great for a coarse grind, like a French press or something like that. And you probably have accidentally found that out.
Yes.
By like having a really weird cup of coffee one time and being like, what went wrong
happened
there?
And the French press is interesting because you're doing a solid liquid extraction and then you're filtering. So you're kind of doing two chemistry techniques at once.
Oh, yeah.
Because in that case, your first part is the extraction, and then you're filtering out. So your coffee is the filtrate and the solids left behind are what's not desirable. So that's kind of fun.
Yeah. And then a double whammy too that I just thought of is that what's a downside on the practical side too is that when you have really fine grind, it also can slow down like water passing through, like a pour over or even a drip coffee machine.
Yes.
But then you also make it much longer that the hot water and the coffee are together.
Yeah.
And then it could get like, more bitter and all that stuff.
Yeah.
Some of the things we don't want to dissolve could happen. And you've probably experienced that too. And been like, why is this coffee so bitter?
Yes.
And also, why is my coffee taking so long to
so
drain
slow.
through?
Yeah.
Yeah.
Fascinating. Well, this has been Coffee Corner with Jam. And I had a great time in Coffee Corner.
Thank you for even doing this topic.
Yes, I was so excited. And it's almost simple and also so complicated that it's hard.
Yeah.
The idea that we're just using water to take out some molecules that we want, simple.
Yeah.
Actually extracting only the molecules we want when everything is soluble in water is very complicated. I would never do that in the chemistry lab. If I wanted to dissolve some things and not other things, I would find a mixture of solvent system that only dissolved what I wanted.
Mm-hmm.
But we only have one solvent option and it dissolves everything. So the only other option is to have a very precise technique.
Yeah. Yeah. That makes sense.
So it really is so complicated and so simple all at once.
Well, it's been a while since we've done this, Melissa, but is it time to talk about what's been going on in our weeks?
Yes, it is. Should I go first?
Yes, please do.
Well, I didn't think about this ahead of time. Well, I'm kind of excited to share this with our listeners. Some people have written in and asked what the progress is like on me graduating.
Oh, yeah. Yeah.
And actually, Jam hasn't heard this either.
Okay.
But I sat down with my boss last week and we looked at all of the deadlines that it would take for me to graduate in spring.
Mm-hmm.
And there's a hard deadline and there's a soft deadline. And then there's a option of graduating in the summer, actually applying in the summer.
Mm-hmm.
And the hard deadline seems pretty impossible because we have a conference, we have spring break, and it's actually the anniversary of when my mom passed away.
Uh-huh.
So that seems like a poor choice.
Yeah.
But the soft deadline, which would allow me to defend and effectively finish in the spring, but technically I wouldn't graduate till the summer, very reasonable.
Uh-huh.
And the summer graduation deadline is even more reasonable.
Uh-huh.
So when we looked at all these dates, my boss and I both thought, I think I will definitely be able to graduate by the end of the summer.
Yeah.
Unless something very bad happens, August should be the latest.
Nice. Wow.
Yeah.
That's crazy.
Super crazy.
And cool that there's more options like that. Like there's not just like the fact that summer's an option and gives you some more time and flexibility, but also is not like a whole year more or something like that. Is great.
It's really nice. And even if I do end up for some reason needing to register for the fall, there are some financial incentives to go in the fall versus the summer. I could defend in August still and just wait to graduate until December, but I would be done.
Yeah.
So no matter what happens, we don't see me graduating after August.
Got it. Very cool.
Very cool and very crazy.
Yeah. Dude, that is awesome.
So I just guess I wanted to share that with you and our listeners that it's truly on the horizon.
Yeah.
It seems like it will be in the next 8 months.
Mm-hmm. Well, dude, that's awesome. Congrats.
Thanks. I'm very excited. Don't congratulate me till it's done.
Well, just whatever the right word is for, that's congrats before it's done, but
How about that's exciting.
That's exciting. And we're all proud that is the case.
Yay.
It's
Thank
going
you.
That direction.
It is nice and weird and fun to think about. There are so many people who know about me trying to graduate and who are excited for that to happen too. So that's kind of cool.
Yeah.
That definitely wasn't the case when I got my master's degree. There was probably like 20 people who were excited about that.
Yeah.
So that's cool. Now, so what about you, Jam? What's been exciting for you? We haven't had these check-ins. I've kind of missed out on what's going on in your life.
Dude, I feel like probably a ton. And also what's funny is that I can't remember the last time that we did these because I guess it was like late September.
Yeah.
That we had recorded the last kind of standard episodes before we started doing the minis.
Yeah.
So probably lots happened then. But the thing that's really current is that my wife, you know this, just started a new job.
Yeah.
And that's obviously going to have a lot of impacts on our life. It's going to be a positive thing. She's, glad she's making this change. It's hard to change jobs, no matter how long you've been in the previous job. Always new stuff to learn. And she's been in her career as a nurse practitioner for like a while now, but there's still, everything's different when you change, where you're working and stuff like that. So that's been affecting us both a lot because I've been having to watch our son 5 days a week for last week and this week.
That's a lot.
And then she'll start working overnight shifts next week. Mm-hmm. And then eventually, when her orientation kind of introduction period's all done, she'll start working 3 overnight shifts a week.
Right.
But we're used to like that kind of schedule if we're working 3 days a week. So the overnight thing will be different. But right now, having to watch my son 5 days a week has been super different.
Yeah.
And on one hand, I get more time with him, so that's really fun.
Yeah.
On the other hand, normally watching my son is one of my like sort of 3 main things I might spend my week doing.
Right.
And so I do like a little bit of freelance. Normally I do like a little bit of freelance, watch my son, and then also do my main job, which is to work for our church.
Right.
And then also at some point in there, I do the podcast.
Right.
So depending on the week, 3 or 4 things that are kind of my job. So the past 2 weeks have been way
heavily skewed.
on the parent side. And that's meant a lot of things have shrunk. So that's been very odd.
Yeah.
And a different kind of tiring.
Yeah.
Where I'm like, in my mind, I'm hoping I'm going to have more time. Say like after I put my son to bed, in my mind, I'm like, oh, okay, cool, I'll get stuff done. But then I'm exhausted because I've been working all day.
Right.
In a different way.
Yeah.
And
normally you just get to rotate some of those working all days with your wife doing that.
Yeah.
So I can see how suddenly having a much bigger load of that for a period of time would be really weird.
Yeah, exactly. Like my first day, like sort of off where I'm going to not be watching my son is on Saturday.
Yeah.
And so 5 days in a row of watching him. And then it's like there's all kinds of things that are building up that I'm not getting to work on between then and now. And so that's tough, but it's good. It's going to be good. And that's kind of probably the biggest change right now this week.
Right.
It's happening right now.
You're in transition, but it's transition to make things less busy and hectic later on.
Yeah.
Right now it's harder.
Mm-hmm.
Soon it will be easier.
Yeah. And we are still of the impression that this will be a better job for M for the next season.
Right.
We'll see how long, but like that is still what we're thinking. So
yeah.
So we're hoping that still pans out.
Well, I don't know why you're complaining because it seems really easy to watch your baby and get all your work done and keep yourself alive.
Yeah, you're right. It's a good point. I guess I'm just I don't function at as high of a level as most people. So
just kidding. That's really hard to still be expected to fully complete your job and fully be on childcare duty is really hard. So that makes a lot of sense, but you're doing great. And it's probably time you'll look back on and be thinking, wow, this was so fun when I got to spend all of that time. Even though it was hard to juggle everything, I think you'll be glad in the end that you get so much time with him.
And I really don't complain. I do tell people about, like, here's what's going on these couple weeks.
Yeah.
Just so they can be a little more understanding of, like, why I might be forgetful or why I might, like, not get back to them soon or whatever.
Right.
But in general, I have not said it like, oh, gosh, pray for me because I'm, or whatever. I haven't been, like, complaining about it because it is really, there's a lot of fun.
Sweet. Yeah. Sweet to get to hang out with your kid all the time, but not conducive to your working environment.
Exactly. Yeah.
Yeah. Well, you've gotten all the stuff you need to get done to get this podcast out. Hopefully, if you guys are listening to this on Thanksgiving Day.
Yes.
And hopefully all of you are both aware of some of the implications of this national holiday and also really utilizing this time to get to be with people that you love and care about and take rest and time off work and remember what's most important in life, like hanging out with your son or whatever.
Yes, definitely.
And thanks also, well, I should say, so happy day to do all of that.
Yeah.
And in spirit of the day, I'm very thankful for all of you listeners and for you, Jam, letting me come and nerd out about chemistry regularly. I feel so lucky, and I'm really excited for this new schedule and thankful to get back into recording regular episodes.
Yes, absolutely. Well, thank you for teaching us. And I want to say also thank you to you listeners. We love what we get to do, and we love that you guys care and listen.
Yeah.
And it's the best. So y'all are the best. Thank y'all.
Thank you.
So while we are having our respective Thanksgiving time or whatever, and you guys are too, if you live in the U.S. or you celebrate that day, just know we're thinking of y'all. So, and we're thankful that you guys send in topics and ideas and questions and stuff like that. It's always so fun. And so if you have any ideas or thoughts, you can send them to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/Chem for Your Life to donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode could be found in our show notes or on our website. Jerem Robinson is our producer, and we'd like to give a special thanks to V. Garza and S. Navarro, who reviewed this episode.